Good morning, everyone. We are going to get started here. So, I guess what I'll do to start. So this is being recorded. So if you need to send this to somebody after the webinar, feel free to do so. My name is James Keston. I'm the Director of Venture Growth at COVE, and we're here to talk today about the launch of the 2025 Naval Technology Innovation Challenges. This year, we're focusing on solutions that are promoting greater sustainability and increasing productivity across the Aegis contract. And so I'll be here presenting today with Thales Canada, and the program is supported by ACOA as well. And so if there's any questions throughout, we're going to leave the Q&A open. I don't think anyone's able to actually turn their mic on or anything, so just drop a question in the Q&A or the chat, and the team will get to those sort of at the end of the presentation. So with me today, and I'll ask the guys to raise their hand, turn their mic on, just say hello quickly. We have Mike Scott, Service Delivery Manager, Technology and Planning Manager. Eric Franson, Marine Electrical Systems Technical Specialist and Life Cycle Manager. And Trustee Dave Peterson, Engineering Delivery Manager, Aegis Capability Sustainment. So today we're going to go through the challenges that were selected to be pursued this year, and that was done with the input of the RCN and DRDC as well. So for anyone who wasn't able to see the launch of the challenges at H2O a couple of weeks ago, this is a good introduction for you. And there's about a month left for people to submit applications, and we'll get to that shortly here. So after the success last year with the challenge program, we're really excited to introduce 3 new challenges this year. We were given a list of around 25 from Thales that were of priority to the RCN, to Thales, and to DRDC, and so we've down selected that to 3 that we think are going to have the most traction with the companies that we work with. And so we have the funding to pursue 2 of those, but we're proposing 3 challenges that we really are interested to see what the ideas are, and whatever the best 2 ideas are, those are the ones that we're going to go forward with. So as I mentioned, this program is supported by Thales Canada, as well as the Atlantic Canada Opportunities Agency, ACOA, who are contributing towards the award funds. Ultimately, Thales wants to accelerate the Aegis Innovation Roadmap, and ideally we'll be proposing the resulting solutions as a value engineering change proposal to the RCN, and in the ideal case, the technology gets deployed on the platforms. So we're really excited to have this partnership with Thales and ACOA and offer the challenges and help identify the SMEs that are going to be working, developing, and testing with the team here. So thanks everyone for joining us. So I'm going to dive in a little bit, just quickly, high level, what the challenges are and what we're doing here. And then I'm going to have the Thales team introduce each of the challenges one by one. And we have 2 new recruits this year, so I'm excited to have more Thales personnel joining the program. So Thales holds the Aegis contract, the Arctic Offshore Patrol Ship, Joint Support Ship in-service support contract. So this includes refit, repair, maintenance, training for the Royal Canadian Navy's new Arctic Offshore Patrol Ships and Joint Support Ships, and is the largest in-service support contract in Canadian history. As I mentioned, we're putting forward 3 challenge statements. We're moving forward with 2 of them. What you will learn from these challenge statements, though, is that all 3 of these are high priority, and so it's a little bit of information for you as to what is the Navy thinking about right now, what is Thales thinking about right now in terms of innovation, in terms of solving problems. And so whoever are the successful companies that will be going forward through the program will receive $187,500 over the course of 4 milestones that must be met through that program. And all of the solutions that are proposed should not be commercialized already, readily available on the shelf. We're looking in the sort of TRL 6 and above range because innovation is going to be required. So if you have technology that could be, tech transferred, or something that needs a little bit to get across the line and pilot project, to commercialize, this is a perfect opportunity to do that. If you have a technology that you need a partner on some other technology to partner with to provide the solution, this is a great opportunity to pursue that partnership and get some new technology developed and get some exposure for it. Any of the IP that is developed through the program remains with the company. So even though the funding comes from Thales and ACOA, they're not interested in retaining any of the foreground IP or the background IP. So that will remain with the company, and Thales will receive just a license to operate, to use the technology, and that's part of the program. So for now, we're going to dive a little bit into the challenges in detail. So first we have Eric Franson, who's going to be speaking on the Innovating Autonomy for Lean Crewing Challenge. And Eric, I'll ask you to unmute yourself and turn your mic on, or just we'll get you going here. So over to you.
Good morning. My name is Eric Franson. I'm a 26-year Navy veteran who now works for Thales. I'm employed on the M-Wave contract, the Minor Warfare and Auxiliary Vessel contract. We focus on the ships such as the Marine Coastal Defense Vessel, the Orca class, diving tenders, tugs, and so on. But at the same time, I'm also work with the team on the Aegis contract as well. And I'm very familiar with those vessels, as prior to retiring from the Navy, I had the opportunity to sail on them. My sailing experience includes extensive sailing experience on the Canadian Patrol Frigate, the Marine Coastal Defense Vessel, as well as the Arctic Offshore Patrol Vessel throughout Canada, the Arctic, the Caribbean, and around the world for many deployments and missions. So this challenge is regarding lean crewing. So reducing the crew members required on the ship to potentially obtain and do the same tasks that are being done with the crew members, the numbers that are presently on board. So as you can read, naval ships face barriers to adopting lean crewing due to requirements for redundancy, flexible staffing, and strict risk management. Certification bodies also enforce standards to ensure mission readiness. This challenge seeks innovative technologies that benefit ships and their crews, facilitating lean crewing. Now, one thing that is you'll notice or you'll discover in delving into this challenge is that there's differences between the crewing numbers required for major warships, such as the Canadian Patrol Frigate, whose task and mission is to potentially, go into conflict, and patrol vessels such as the Arctic Patrol Ship, whose is a patrol vessel by nature and doesn't have the same armament and potential risks that it will see when it goes to sea with its crews. So as such, much of the crew numbers on a vessel are dependent upon the task it could potentially be given by the government when it leaves the harbor and goes on deployment. So next slide, please. So challenge number one, the criteria for this challenge. The solutions must be practical, resilient, and purpose-built for the realities of life at sea. Proposals should envision the following: improved human safety, reduced human error, lower equipment and ship operating risk, and enhanced confidence and functionality of ship equipment. For each of these four criteria, based on my own personal experience as a sailor, I'll give you 4 examples to go along with each of these. So for improved human safety, on board a ship, we have what's called damage control rounds persons. When a ship encounters damage due to conflicts such as missile or torpedo strikes, groundings or collisions, or explosions due to fire at sea, then we close up what are called section bases. In these section bases, individuals are sent out throughout the ship to discover, assess, and report back damage so that appropriate action can be taken by command to combat this damage and prevent further damage to the vessel and harm to the crew. So this is one area in which technology could probably play a huge role in improving human safety, expediting the flow of this information back to command to make appropriate decisions, and get repairs done more quickly to better ensure the safety of the equipment and the personnel. Reduced human error. One example from this, which I've seen throughout my career, human error that has caused environmental issues, as done with fueling. Fueling on board a Navy warship requires a huge number of people due to the redundancy that is utilized to dip tanks to confirm the amount of fuel going into tanks prior to the engineering department switching tanks from one tank to another to ensure, because a warship has multiple tanks and they're filled one after another. So it takes many people to do this. And although the technology is used to monitor this, there's also a redundancy of personnel that are used to measure these manually. So this is one area where human error has played a factor in causing environmental issues, where fuel spills have accidentally occurred, and it's been to the detriment of the Navy when this has happened. Lower equipment and ship operating risk. In this example I'll use is optimizing planned maintenance. One example I'll use for this is, as a technician over 15 years ago, we used to do planned maintenance on motor control overloads. It was deemed after so many failures of these overloads that the problem was over maintenance. There was too much maintenance being done on these overloads, so they were being taken out, tested in the shop, and then reinstalled. So this was just one example that was captured by the lifecycle material managers in Ottawa, and this maintenance was discontinued. Unoptimized, technologically advanced ways of monitoring planned maintenance could lower the risk of over maintenance on systems, or perhaps more optimized maintenance on systems, thereby saving the Navy money and optimizing the machinery on board the vessels. And lastly, the enhanced confidence and functionality of ship equipment. The example I'll use for this one is nothing ruins a day more at sea than when the black water system goes down. The black water system on board is obviously essential for the crew. So if there's a way in which an organization such as yours could find a way to make the black water system more reliable, it's very susceptible to foreign matter being entered into the system, and thereby shutting it down and making it unusable to the crew. That is one example I would use for that. So successful applicants should demonstrate maritime readiness, operate offline, and be deployable within 2 years. So I just thought I would include these examples based on my years of experience as a sailor to give you some sort of idea of the items that we might be looking at here. However, feel free to inquire about potential other examples, and we're always here to provide assistance. Thank you.
Thank you, Eric. So as you can hear from what Eric mentioned, this is a fairly broad challenge with any number of different solutions, and I'll run through the website quickly. There's some more examples on the website just to spark some ideas, but really we're hoping to see what it is that you come up with. So the next challenge we're going to have presented by Dave Peterson, which is innovating automated inspection and analysis of maritime infrastructure. Dave.
Hey, good morning, everybody. First, let me say thanks to everyone that's coming out to participate in this webinar today and gather more information on these challenges. We're really excited about these challenges. We're really excited about this program. We're a couple of years into it now with COVE, and it's really starting to generate some success and excitement, and really happy about this next set of challenges. So my name is Dave Peterson. I am the Engineering Delivery Manager for Aegis Capability Sustainment, which is a mouthful to say the least. But what that basically means is I lead the engineering change team for Aegis. So any of the changes that are made to the ships go through my team and subcontractors and you name it. I like to say that we are the space between innovation and integration in putting new capabilities and technologies on these platforms. One of the challenges that we find with the ship is really understanding the hull below the waterline. We spend a lot of effort in maintaining and understanding the material state of all of the systems inside the ship and all of those external surfaces you can see above the waterline. But with the exception of periodic diving and dockings, we don't understand the hull quality very well, and especially you've got a ship that operates in sensitive Arctic areas. You've got a ship that is deployed far away from home with very little supports. Developing a capability that can help us see the underside of the hull of the ship is a huge value asset to us, both from a maintenance side of things. If you have a collision or a grounding, being able to understand the extent of the damage. There's also systems underneath the hull that are important to the operation of the ship. So understanding, the state of those systems is extremely helpful to us to be able to provide maintenance to the ships. But then you think of, the same capability in the hands of the sailors themselves. These ships don't often travel with dive teams on the ships, embarked on the ships, unlike our patrol frigates. So having a user-friendly capability that the sailors can deploy over the side of the ship and help in issues of damage, or even being able to understand the bottom surface of an area where a ship is moored or where a ship is docked, so on and so forth. This is the concept of a capability that we're really looking for solutions are. Is how can you tell us what's going on around the underside of the ship, and what sort of capabilities or technologies can you pack into that solution to provide value added, a value added return. So can you do modeling of the damage area? Can you do visual inspection? Can you understand the quality of the steel or the coatings underneath? Can you detect marine growth? All of those things. So next slide there, James. So we're really looking for innovative solutions that can help us with these use cases. And we need to be mindful that, solutions ought to be able to be used by nearly any sailor and nearly any naval architect. So simple to use and simple to deploy, but meaningful in the amount of data and quality of data that it can gather for us is really important. So that's the challenge. The second challenge is automating underwater hull inspections, or other important infrastructure is a capability we'd like to see developed through this challenge.
Great.
All right.
Thank you, Dave.
Yeah.
As I mentioned at the start, we're going to stick around after this to answer questions, and the team here is all going to stick around after we sort of finish the presentation to answer any specific questions. So we will have time for that. So the third challenge is called additive manufacturing for ships. This is also a bit of a broader challenge, and we've asked Mike Scott here to speak on the challenge. So Mike, over to you.
Yeah, thanks for letting me participate in this. I'm excited. I guess a little bit of background for myself. I've been about 15 years plus in the marine industry. Started on the tools, moved into the planning world, and a background that relates particular to this challenge is for a few years I managed the material group within our Department of Service Delivery, and finding parts, even on brand new ships, is extremely difficult at times. One can appreciate the configuration requirements and certain standards that need to be met. In addition to a lot of components are custom built for that specific ship's applications. Therefore, going out and purchasing replacement parts years later is very difficult because it requires the manufacturers to basically retool, and timelines like that can be critical to deployments. Any operations, a few hours could mean a lot, but in supply chain, months of a delay is not uncommon. So yeah, we've been creative of checking higher assemblies and things like that in order to get the required parts to get the ships to sea. However, that cost is not ideal, especially for something that could be replicated. So I guess if you want to go to next slide there, James. So the first bullet point is actually a huge hurdle for what we actually see in our supply chain, where a lot of documentation is absolutely required, and parts being replaced need a lot of approvals through engineering and life cycle management. Something like this, having almost a predefined requirement, would expedite that timeline extremely. So having pre-compliant parts basically ready to go at a moment's notice, ideally by ship staff, would be an absolute game changer in the supply chain. There's definitely the technical and operational challenges, in the sense that that part is very unique and would require significant amount of prepping prior to an additive manufacturing, to ensure that, yes, it may look like it, but it's going to function like it too. And the skills and development kind of goes to the first challenge, where, yeah, there's a lot of overturn in developing an easy to use type product. It's absolutely crucial, because if it's not intuitive and requires significant training, then chances are of having somebody available to use the application would be kind of make it a moot point. But yeah, I look forward to the challenge. I think it'd be pretty cool.
Great. Okay, thanks, Mike. So for anyone who is successful going through the challenges, these are the three gentlemen that you'll be working with over the course of the timeline, which I'll share here in a minute. So we're going to go through a little bit more of the additional considerations, but also selection process and eligibility as well. So as I mentioned earlier, we're looking for technologies that are at TRL 6, 7, 8, something that's not off the shelf, ready to go, that has strong potential to become integrated into the ship and become a viable solution. So we're not really interested in ideas that, you know, are maybe a little bit more out there, but probably won't get implemented. Something that we can see actually being implemented will have a higher success rate through here. Navigating regulatory hurdles, which is a big challenge for that third one with the additive manufacturing, and then just making sure that you have some kind of awareness of security and clearance requirements. If we're going to be doing testing that involves, you know, getting secure goods clearance, we'll have to do that very early on. Okay, so for the selection process, I'm going to quickly go through that here. And so the rules and requirements. So in your proposal, your application, I'm going to pull the website up shortly, but there's sort of 6 areas that we're looking to identify. So what is the solution, and what is the impact of that solution on Navy operations, Thales's operations, and also impact of winning this award on your company as well. The novelty of the innovation, so how far do you need to take this thing in the timeline given, and how novel is the idea. The organization's capacity to execute, so we want to make sure that there's the right people that are working on the program and that they have the time to do so, because this is a commitment to bring some technology forward and get it ready for piloting. Looking at the team's experience and the technology that has been developed to date, you know, that's obviously very important to make sure there's some credibility there. The level of innovation that's required, and then some sort of look at the development roadmap. So not just for the 6 months of the program, but like what might it look like from that point forward as well will be really important when we're assessing the applications. So how do you apply? So there's there's a portal here, and I'm going to pull up the website quickly, just so I can show you what that looks like. If I can find it, here we go. Can you see that? Yeah, okay, great. So here's the website. You'll be going to coveocean.com/challenges. That'll pull it up. There's QR codes. You can email myself or challenges@coveocean.com. It'll be posted through socials as well. You should be able to find the website. If you can't, come find me. And it's pretty straightforward. We have everything laid out here. If you're going to be looking, I guess I'll go through. So the webinar will be posted here once we have the recording. And then there's the timeline here if you have questions afterwards. And then some FAQ down here to answer any questions as well. I'm just going to quickly jump into just the first challenge to give you an idea what this looks like. So there's more details here to look through on what we're expecting in your application. And for the lean crewing one, some other ideas on some areas that you could be addressing with your solution. There's some more details on rules and requirements, eligibility, the evaluation process, which I'm going to go through in the presentation, so I'm not going to do that here. I'm just going to show you what the application looks like. So you'll click Submit Application. You will go here, click on the challenge that you're hoping to apply to, and start putting your information here. There's a button at the very bottom of this to save your work. So if you want to start working on it and save it for later, you can use that button. You can also obviously work on this in a Word document and copy it out afterwards, whatever suits you. So I will take us back to the presentation. So you can use that QR code and feel free to reach out to us at any time, challenges@coveocean.com with questions. So who can apply? This is similar to previous years where the lead applicant must be an Atlantic Canadian company. That's partly because of the support by Atlantic Canada Opportunities Agency. And so companies can apply on their own or partnered. We're looking at small and medium-sized businesses, less than 250 people. And the lead proponent, as I said, must be incorporated within Atlantic Canada. But that doesn't mean that somebody from outside the region could apply. They would just be working with a company that's located here. So post-secondary institutions are able to apply, as well as not-for-profit organizations, but they must apply with a for-profit, a small medium business or Indigenous organization. So that's the eligibility. And if you are a company listening right now that is not registered in Atlantic Canada, let us know that you're interested. Write us an email, tell us what it is you're thinking about, and we might be able to pair you with other companies who are thinking of a similar solution or might need a particular capability to apply. So this year we'll have a set of judges for each panel. There will be a Thales representative, an Aegis representative, someone from COVE. We have an expert from IRAP who's familiar with the areas for each challenge, and then we'll be having an independent industry expert as well from an organization that's not applying to the program. They will be selecting the winners. Looking at the scoring, so there's sort of the six areas that I mentioned before. They are weighted. So the most important areas are going to be, do you have the resources to do this? And how does your solution fit with the challenge topic? Next up will be the impact of that solution. So if it's a small impact, it's going to have an impact that will affect your score. If it's a larger impact, that will be obviously very good. And then followed by the expertise of the team, the timeline given the 6 months of development, but also the timeline that you've thought about going forward from there, and the level of innovation required is the smallest component of that. So looking at the timeline, so we launched at H2O June 12th. The applications opened then. They will remain open until July 25th. Obviously, we're having our webinar today, so we have about a month left in the application phase. We'll then be evaluating submissions from July 28th until the 5th of August, and the winners will be notified on August 11th. And then we'll be working on the development and the program management from September until end of March. And for that phase, we'll be working with closely with the team, the guys you've heard from here today. I mentioned 4 milestones earlier. So the idea being that we're able to help you realize this technology by with the award fund. So being able to dedicate people and resources to the program. So through the first milestone, getting the kickoff and selection, there'll be a 25% of the prize money distributed. Through the preliminary design and an implementation plan, once that's approved, 35% of the funds. So you'll have over half of the money at the second milestone, which should enable you to get through to the third milestone, which is the detailed design review and a testing plan. And then the fourth milestone is the final solution is delivered, tested and accepted as meeting all project requirements, and those project requirements will be set out in the kickoff meeting at the start. At that stage, Thales will be issued the license for a set time, and 25% of the money, the final bit of the award funds, go out after everything is signed off at the end. The R&D should take place in one of the 4 Atlantic provinces, so that's just something to be aware of as well if you're working with a partner. So we're obviously, as Dave mentioned, like we're really excited to see the partnership continue to grow, and we love collaborating with Thales. They've been a great partner in all of this, and so this is a real opportunity to bring some new technology forward and get new ideas hopefully deployed with the RCN. So thank you to Thales and ACOA, and I think now's a good time to open the floor up to any questions. So what I'm going to do, I'm going to switch over here. No, I'm going to switch over here.
We have 5 questions.
We have 5 questions? Okay. So hopefully they're directed to someone. I will read them off, and I will assign one of you. Okay. So we'll start at the bottom. Who was first here? Robin. Okay. Robin says, how does this differ from the naval program of the exact same name, or are they one and the same? Also, is this only for East Coast companies or open to all? So I answered one of those already, but I'll just reiterate. This is the 3rd installment of the challenge program of the same name. So we completed 2 challenges in 2018. No, we did the first one in 2022. So there's another program that I'm not familiar with from 2018. Robin, you can write in here if I'm mistaken. And then 2 challenges last year, and this year we're proposing 3. We're going to go forward with 2. We have an agreement with Thales for 5 years of this programming. We're hoping to offer more and more challenges as the years go on, but that's there will be more coming. As to East Coast companies, as I said, the lead applicant should be from one of the 4 Atlantic provinces. Partner companies are able to be from anywhere. Maya, hi Maya. Is there anywhere we can learn more about the compliance requirements, regulations for parts for ships in relation to the additive manufacturing challenge? I think maybe Dave, do you want to take that one, or Mike perhaps? I know you had some thoughts on this earlier, Dave. Mike? Or not?
Yeah, well, for myself...
Go ahead, Mike.
Oh, sorry. I wouldn't want to, in this forum, suggest an exact spot. I know I can provide James with some references later, but Dave, unless you know off the top of your head.
So
yeah,
maybe I can take it in the abstract. If you think of welding, which we really understand welding. We have decades and decades of empirical evidence. We understand what a welding defect looks like. But that isn't true for additive manufacturing. We don't have ready inspection methods. We don't have ready, understanding of what defects look like. So potentially a solution in that space could be, a technology that helps identify defects in additive manufacturing. And in reality, like additive manufacturing is new-ish as a capability and as a growing as an industry, but we don't have that same sort of regulatory oversight that we do for, an example like welding. So hope that answers your question, but feel free to give a follow-up.
Okay. Ulash, is the wireless transmission of visuals from the hull as well as the ocean bottom to the bridge of the vessel of interest for Challenge 2, in particular using wireless modems mounted on small AUV scouts hovering around the hull?
Boy, that sounds like a really sweet capability, and hopefully we get a proposal that highlights something like that. The quicker
Great.
you can get data on board a ship from where we gather it, the better it is, and the easier use it is to do so. Absolutely. So look forward to seeing what ideas come from that.
Great. Okay. Thanks, Ulash. Alexander, eligibility. Is this challenge? Is this challenge open to BC-based companies? Okay, so similar to before, if you are from outside of one of the 4 Atlantic provinces, you are able to apply. You will just have to make sure that you have a lead company that you are proposing with that is from one of the 4 Atlantic provinces. So a good opportunity to build a partnership in the region. And if you're not sure who might be a good fit for what you're thinking about, send me the idea. Is my email is not there. Send it to challenges@coveocean.com, and we will make sure that we take a look at that and consider some potential partners for you to speak with about applying together. Okay, Sam, if our proposed solution is a module within a larger software platform that is already at TRL 9, but the specific module we're submitting is currently approximately TRL 6, would that be considered acceptable under the challenge criteria? As far as I'm concerned, yes. I see Dave shaking his head there, or nodding his head there as well. So yeah, I think that would suit fine.
Absolutely. I think that ticks both boxes. Is you're bringing a mature capability that has aspects of when we go to convert a technology into use after the development phase, but also satisfies that need that that capability isn't off the shelf right now, and we can enhance it with some R&D and make it more off the shelf. So in my mind, that exactly fits the intent here.
Yeah, and kind of to Dave's point, one of the things that's nice about a solution like that is, we only have so much time to get this across the line, and so having something that is proven but not off the shelf yet is kind of the sweet spot that we're looking for in these proposals. So that comes to the end of the questions. Is there anything in the chat? I'll just check quickly. I don't think so. Great. Okay. If anyone has any other questions, feel free to reach out at challenges and at coveocean.com. I will make sure that we have these 3 gentlemen's minds on the topic as well. And they've also said they're happy to answer questions. I asked them beforehand. I'm not speaking out of turn here. So feel free, and we can make sure that we get them into a conversation with you while you're thinking about your applications. Thank you very much for your time, and yeah, enjoy the rest of the sunny day here in Atlantic Canada. Goodbye, everyone.
Yeah, thanks everyone. Cheers.
Thank you.